Hi, today we're going to be talking about real numbers in the number line. This is section 1.3 in your book. There'll be a lot of definitions that we will discuss in class the next day. But take notes and try and understand them as best as possible. So let's start talking about sets and subsets. A set is a well-defined collection of objects. For the most part, we're going to be talking about numbers. Those are our objects. Each object is called an element of the set. If I have the set A, I'm just making this up, it's a set of numbers 1, 2, 3, 4, and 5. My set, 1, 2, 3, 4, 5 are all elements of the set. Subset, the set of elements from the original given set. So if my set A is 1, 2, 3, 4, and 5, subset of A could be 1, 2, and 3. This is going to be a subset of A. Because all the numbers in the subset belong to the original set. Another one could be 1, 4, and 5. That could be another subset of A. 1, 4, and 5 belong to A. Natural numbers are the set of positive numbers that do not contain a decimal, such as 1, 2, 3, 4, 5, 6. Basically, these are the counting numbers that you learned when you were in, let's say, kindergarten. You learned to count with the natural numbers. Whole numbers are the same thing as the natural numbers, except it contains 0. 0 is included. What's 0, 1, 2, 3, 4, 5? One way to think about that is that there's an O, the word whole, so it contains 0. And finally, integers, a set of positive and negative numbers that do not contain a decimal. These are the positive and negative counting numbers. So -2, -1, 0, 1, 2, 5, 8, 100, 137, 1,296, -13, -287. They're all integers. This is what they look like on a number line. Notice that 0 is not included with natural, but it's included with whole, and then integers have all the positive and negative counting numbers. Rational number. This is important for you guys to understand that a rational number is any number that can be written in the form of a over b, where a and b are integers and b does not equal 0. Basically, if you can take any number that exists and write it as a fraction that is equivalent to the number itself, rational. A rational number can be a decimal, repeating, or terminating, or an integer. The integer can be written as itself over 1. So if I look here, number 5 is an integer. I can write that as 5 over 1. -3 is an integer. I can write that as -3 over 1. What about if we have a decimal that's terminating, a decimal that ends? Well, I can rewrite this as 33,456 over 100. Those two are equivalent. The -8.2, we will talk about this later on. If you ever have a repeating decimal, you can always put it over 9. So if I wrote -8.2 repeating as a fraction, that would actually come out to -74 over 9. You can check that on your calculator, but I believe it will come out to -8.2 repeating. Irrational numbers, any number that cannot be written as a fraction. Well, almost all square roots are irrational unless they equal a rational number. For example, the square root of 13. If we put that into our calculator, it comes out to a very long decimal with no pattern. This is irrational because it doesn't come out to a rational number. It equals a decimal with a long decimal that does not have a pattern. Pi is irrational. You cannot write pi as a fraction. Basically, rational and irrationals are completely different. They make up a set of numbers called real numbers. So on this chart right here, really important because it's a diagram of all of the real numbers. So what it says over here is that all whole numbers are considered integers. The way to think about that is that whole numbers are a subset of integers. anything that's a whole number can be an integer. There are certain things that are integers that cannot be whole numbers, and those are negative counting numbers. Integers are a subset of rational numbers. Whole numbers are a subset of rational numbers. Like 5/8 is a rational number. -3 is a rational number. 5/8 is not an integer. -3 is. This is part of the real numbers. Irrational numbers, the other half of the real numbers. This is a diagram explaining subsets of real numbers. The radical symbol is used to indicate the non-negative square root of a number. For example, the square root of 25 is 5. And then down here, the only way we can get a negative is if I have a negative sign in front of the square root, in front of my radical. Well, it's asking, what is the negative square root of 25? And that's -5. So radical only has one solution. The question asks, what are the square roots? Notice the S, making it plural. There'll be two answers. If you just see the radical sign with a number under it, it's asking for the non-negative answer, which is the positive answer. Find the square roots of 196 and 49 over 100. The square root of 196, positive 14. The square root of 49 over 100, well, square root of 49 is 7, and the square root of 100 is 10. Finally, estimating a square root. Knowing many of the perfect squares can help us determine the square root of a number that is not a perfect square. So, estimate the value of the square root of 39 to the nearest integer. Well, I know the square root of 39. 39 lies between the perfect squares 36 and 49. So if I took the square root of all three of these, I found out that the square root of 39 lies between 6 and 7. If I go to my number line, I see that's between 6 and 7. Next, notice that 39 is closer to 36 than it is to 49. Therefore, on my number line, I know that the square root of 39 is going to be closer to 6 rather than 7. Therefore, square root of 39 is about 6. It's a little over 6. Hopefully you found this information helpful. We will be talking more about this in class. But I hope you have a wonderful rest of the day, and I will talk to you later.